In previous lectures, we have studied pure resistive circuit, inductive circuit, and capacitive circuit. Now we see the combination of resistance and inductance. See here, this circuit is known as RL circuit. In RL circuit, first we consider resistance R ohm and inductance L Henry connected in series. See here, by considering the circuit, we connect resistance R ohm and inductance L Henry in series along with the voltage source V is equal to Vm sin omega t. This is R ohm, this is L Henry. In resistance, voltage and current are on the same phasor, and in inductance, current lags behind the voltage by an angle 90 degree. ठीक आहे. तर विद्यार्थी मित्र, आपण आर एल सर्किट पाहतोय. आर एल सर्किटमध्ये आपण प्युअर रेजिस्टन्स हा आणि प्युअर इंडक्टर हा सिरीजमध्ये कनेक्ट केलेला आहे विथ द व्होल्टेज सोर्स. दिस सर्किट इज नोन ॲज सिरीज सर्किट. रेजिस्टन्स हॅविंग व्हॅल्यू आर ओम अँड इन रेजिस्टन्स व्होल्टेज अँड करंट आर इन फेज. आपण आर रेजिस्टिव्ह सर्किटमध्ये पाहिलं आहे का व्होल्टेज आणि करंट काय असतात, एकाच फेजरवरती असतात. आणि इंडक्टरमध्ये व्होल्टेजपेक्षा करंट हा लॅग असतो. करंट इज लॅगिंग बिहाइंड बाय अन अँगल 90 डिग्री. सो दिस voltage is V is equal to Vm sin omega t. Because of this voltage, current starts flowing through the circuit. The value of current is I. I is equal to Im sin omega t. But in pure inductive circuit, current lags behind by an angle 90 degree. RL circuit, we can combine these two phasor diagrams. We get, if we combine two phasor diagrams, let us see, this is voltage, this is current I. We can consider this current is IL, current flowing through the inductor, and here current IR, the current flowing through resistor. If we make phasor sum of these two currents, we get the total current flowing through the circuit. I is equal to IR plus IL, and this angle is phi. So we can say that in RL circuit the phase angle is in between 0 to 90. Phase angle is between 0 to 90. Because of this voltage, current I starts flowing through the circuit. So we get the equations for voltage V is equal to Vm sin omega t. Hold, there is no change in voltage equation. Voltage equation remains same. Because of this voltage, current starts flowing through the circuit. Current I is equal to Im sin omega t minus phi and ampere. The value of phi is in between 0 to 90 degree. Now we see the waveforms of RL circuit. See here, this is the voltage, waveform. This is time axis 0, pi, 2 pi. This is voltage V is equal to Vm sin omega t, and current in this RL circuit, current lags behind with the voltage, but the angle is less than 90 degree. So see here, this is 90 degree. We can draw current as time axis. This is the current is in between 0 to 90 degree. We can say that current waveform starts from here. This waveform shows the current waveform. this is I is equal to Im sin omega t minus phi ampere. Here 0, and this is the phase difference phi, which is less than 90 degree. Now we see phasor diagram. See here phasor diagram. This is the voltage axis. Phasor is a straight line having arrowhead on one side. Its length represents the magnitude of an alternating quantity. See here, this is current IR, this is voltage V, this is current IL, current flowing through inductor, current flowing through resistor. If we combine these two currents, or we take phasor sum, we get total current flowing through the circuit, and that current is I is equal to IR plus IL, total current flowing through the circuit. But this current lags behind the voltage by an angle phi, and the value of phi is in between 0 to 90 degree. 0 to 90 degree. We can say that here phi is in between 0 to 90. Phi is in between 0 to 90 degree. 0 to 90 degree. Now we see the impedance of RL circuit. Impedance of RL circuit. Fifth point, impedance. Impedance is Z. The impedance of RL circuit is Z is equal to R plus JX ohm. This is rectangular form. This is rectangular form, and in polar form Z is equal to R angle phi ohm. This is polar form. This R can be calculated as R is equal to under root R square plus XL square, where here because of inductor X becomes XL, and phi is equal to tan inverse XL upon R. Tan inverse XL upon R. In this formula, by using this formula, we can convert this rectangular form of impedance to the polar form. Now we see after that power. Power in RL circuit is the P is VI cos phi, or VRMS into IRMS, watt. This is the power flowing through RL circuit. Now we see energy. Seventh point, energy. E is equal to P into T joule. E is equal to P into T joule.